This video is a quick tutorial about the differences between atoms, ions, and isotopes, looking at some of the characteristics that are the same and some things that are different. So we have learned about atoms, and we've learned that the atomic number is the same as the protons, and in the case of an atom, it's the same as the electrons. Now that's not always the case, as you're learning when we take the notes on the additional topics here. So this is only in atoms. The atomic number is equal to the protons and it is equal to the electrons. We've also learned that the atomic mass in an atom is equal to the protons and the neutrons. Because they both have mass, we add them up together. They both exist in the nucleus, so the atomic mass is equal to the protons and the neutrons, and you just add them together. Now if you're looking for the neutrons, you might take the mass minus the protons to find the neutrons. These are neutral, meaning they have no overall charge, and we can also expect them to have the mass typically that's on the periodic table. So the mass will match the periodic table. Okay, so that's atoms. Now let's go ahead and look at isotopes. In an isotope, we have changed the number of neutrons. You might have gained, and you might have lost the neutrons that were listed. And isotopes will have an overall different mass as a result, because as you can see over here, the atomic mass is the protons plus neutrons. So if you have more neutrons than you had in an atom, you would have a different mass, or if you have less, you would also change the mass. And so isotopes are going to have different masses than on the periodic table. So when you're trying to figure out a particular particle, if it's an isotope, and you're looking at the periodic table and you're comparing the mass with that on the periodic table, and you see that it's not the same, then you can assume that it's an isotope. Now isotopes are represented a couple different ways. You might see them written like this, and this is telling me, oops, this should be a 6. This is telling me that I have a mass of 14, and this is my atomic number on the bottom. And so this carbon isotope could be 14 over 6, or we might see a 12 over 6. And so these are two different isotopes. They have different masses, and we would know that the number of neutrons are different. The other way we could write this is we could write it carbon dash 14 or carbon dash 12. And they are just indicating that the mass is different, and then they expect you to find your own neutrons. So you would have to find the neutrons using math and the atomic number. Okay, so you would do that on your own. Otherwise, in an isotope, the protons still equal the electrons. They have not changed, and therefore the protons are the same as the atomic number. Now remember, the atomic number identifies what element you are dealing with. So if the atomic number is 6, we always know that it's carbon. If the atomic number is 7, then that's nitrogen. It just depends on what substance you're looking at. Okay, so that's isotopes. And then we have ions, and in ions you have changed the electrons, because we cannot change the number of protons. If protons change, we have a new element. So you can't change protons, but you can gain or lose electrons. So if we gain electrons or we lose electrons, notice these are both negative. If we have gained electrons, what kind of overall charge would we have? We would have a negative overall charge. And if we have lost electrons, meaning we have less electrons, we would have an overall positive charge. Okay, so if we have gained electrons, we become negative. If we have lost electrons, we become positive. And they have other names for these particular particles as well. So if you have a negative overall charge, you are called an anion. And if you have a positive overall charge, you are called a cation. There's some ways to remember the two differences. I'll let you check that out in a different video. keep in mind that if we are showing carbon, we'll keep carbon here because we had carbon on the other example. If we have gained electrons, we are going to have to indicate that we have gained electrons and we have a negative charge. So you might see carbon with a -4. That means that we have 4 more electrons than we should have. Now, we know carbon has an atomic number of 6, so that is my protons. I would have 6. Now, if I am trying to figure out that I have gained 4 electrons, I would have a total of 10 electrons, because typically in an atom, well, actually, always in an atom, the protons and the electrons are the same. But because this is an ion and we've gained or lost electrons and we have an overall -4 charge, we have 4 more protons than we would normally have, so we have 10 electrons. If we were looking at an ion that is a carbon +4, so here's a different example. If we were looking at carbon +4, and it's still carbon, so our protons are still 6, now we would have a different number of electrons. We have 4 less than we normally have. We would have electrons would be 2, because if you look at the math, we have 6 pluses and we need to have an overall of +4, a discrepancy of 4. We can only have 2 electrons. You can do math here. You can take and you can say, all right, my overall charge is going to be equal to the sum of my protons plus my electrons. So I have 6 protons. And how many negatives can I have here? You can see that in order to make this work, I would have to have 10 negatives. And if you're looking at this other example, I still have a +4, and I have 6 protons, and I would need to add something in order to make it equal +4, and they have to be negatives. So I would have 2. So however you want to think about it, gaining or losing or doing the math, that's up to you. But the difference between the particles of an atom, an ion, and an isotope, the isotope has different neutrons and the ion has different electrons, and they each have their own different calculations involved.